So thank you for volunteering. You're just gonna write it right here on the iPad.
Yeah, no, it's fine.
Yeah, let's zoom in. Why not? Let's zoom in. Zooming into number 1. Go for it. Thank you. Who's next? Number 2. All right. Let's do the ink. Yeah. Okay. Thank you. We're not saying what's right or what's wrong yet. Let's just get some volunteers to do 1, 2, and 3. Okay. Now let's go back and actually talk about these. So, number 1, is that rational? Yep. Yes, it is, right? It makes sense. Negative 2.5, you owe somebody $2.50. That makes total sense. It's not irrational, it's totally rational. It is a decimal, which could also be written as a fraction. A fraction's a ratio. That's how we know it's a rational number. Now, number 2, is number 2 rational? Yes, it's rational, okay? It is rational, but
It's an integer.
But you could be more specific and say it's an integer. Excellent, right? So definitely, I mean, rational is correct. Don't get me wrong, rational is correct. But the better answer would be integer.
I thought because it had a decimal, it would make it back to rational.
And that is an excellent comment. Because it has a decimal, isn't that rational? Because rational numbers are decimals or fractions. But what kind of decimal is this? This is a 3.0, right?
Yes.
So it's really just a negative 3, right? It's kind of like saying if I did 3 over 1, is that a fraction? I mean, you could make it look like a fraction, but it's really a natural number, 3. 3 over 1, you could be specific and say that it's natural. So right here, this negative 3.0, it's really just a negative 3, and that would be an integer. Like I said, the answer rational is not wrong. We could just be more specific and say integer. Okay? Number 3, is that irrational?
Yes.
Absolutely. If you actually did the score to 7 on a calculator, it would be a crazy long irrational decimal. So number 4, I'll tuck the red ink over there. There you go. Thank you. Going for number 5, 1/6 or 1/3. Which one's bigger? Thank you very much. And the last one, number 6, which one's bigger, the 0.08 or the 0.00799? There you go. Thank you very much. So number 4, if you think about the number line, the negative 8 and the negative 10 on a number line, the negative 10 would be further to the left on the number line. So negative 10 is less than negative 8. That's why it's opening up to the negative 8. Negative 8 is on the right side of negative 10 on the number line. That's why negative 8 is greater than negative 10. Number 5, just to review what we practiced yesterday, if I really wanted to easily compare 1/6 with 1/3, it'd be a great idea to get the same denominator. Now this one's already 6, so I don't mess with the 1, but this one I could change it to a 6 by multiplying both top and bottom by 2, and you'd end up with 2/6. And now you could actually compare this numerator with this numerator, and it's absolutely crystal clear that 2 is greater than 1. That's why the answer is less than, because the 1/6 is less than the 1/3. Does that make sense to everybody? Will we be able to repeat that on the quiz next week?
Yes.
Yes? Okay, hope so. And the decimal, just comparing decimals, it's as easy as looking at each place value. If you look at the actual 1's value, that's a 0. That's a 0. So far you can't tell. You look at the next, the 10th's place value, that's a 0. That's a 0. Still looking pretty equal. But you move on to the third one, the hundredths position is an 8. And this hundredths position is a 7. So right off the bat, you know that the 8 is greater than 7. Who cares if there's 1,000 9s after it? The 8 is greater than the 7. So it's a greater than symbol opening up to that 8. Does that make sense?
Yes.
Okay, good. So to give a decimal approximation, what should we all do to be able to do that correctly? What should we write on our quiz or on our homework piece of paper or whatever? We need something to be able to do decimal approximations. Perfect square number list, right? So if you haven't done it, you probably need it. So there's a perfect square number list, and once you have your perfect square number list, you could go put square roots on all of them. That way you could think about the answers to those perfect square numbers, which would be 2, 3, 5. Well, I missed 4, huh? The square to 16 belongs right there. 4, 6, 7, 8, 9, 10, and so on. So when we look at the square root of 48, the square root of 48, when we think about the square roots of all these perfect square numbers, 48 is right before the 49. So if the answer is 7, this answer has to be right before 7. So that would be a what? 6.9, exactly. Now let me just ask for volunteers to do the next 2 answers. So that's correct. The square root of 37 is a little bit more than the square root of 36, so the answer is a little bit more, 6.1. Now the square root of 31, that's almost perfectly in between 25 and 36. So the square root of 25 is 5, the square root of 36 is 6, so the square root of 31 is right about the middle, which would be about 5.5, 5.5. I hope this helps. This will all be on the quiz next week, and it'll all be on Edmodo later.